Hello, y'all. It is probably April 3, or maybe you're watching it early or late. We're going to talk today about permutations. Last time we looked at the counting principle and we said, how many ways can I count to do something? How many ways can I do that? Today we want to look at a special thing called permutations, and that's an arrangement of objects in a, let me get a different color, certain order. Order is important. What that means, if I had 3 kids and I wanted to line them up and I said, y'all get in a line, there would be different. If I just say I want these 3 kids, there's only one group. But if I said they're going to be in a certain order, I can have ABC or ACB or BAC or CAB. Then the order matters. So let's look at this. In general, n factorial is how we figure out how many ways there are. What does a factorial mean? Let's go down here for a second. Factorial is in your calculator. Let me show you a couple of things here before we get started. If you go onto your calculator, can you see that? If you hit your math button and then arrow over to probability, which is where we are, number 2 is NPR. That's going to be permutations. That's what we're studying today. Tomorrow, you're going to use button 3, which is NCR, which is combinations. And then, of course, the factorial button is number 4. So remember where those buttons are. And I want to go over a factorial is something you would have learned a long time ago, but let's review it in case you've forgotten. Factorial means you multiply by every number that came before. So 4 factorial means 4 times 3 times 2 times 1. So that's 4 times 2 is 24. Okay, so factorial means you're multiplying by every number that came before. So for permutations, the general rule, how many ways can I put something in order, is that number factorial. So let's look. How many ways can bobsledding teams finish the competition? Well, let's look. 10 teams are competing in the final round of the Olympic 4-person bobsledding team. Okay, how many ways can the bobsled teams finish the competition? There are, let me get a different color, 10 teams. We got 10 teams. So how many ways can they come in? 10 factorial, which you can type into your calculator with the math PRB4, and that equals, pause the video for a second and practice typing this in. Okay, so pause me. All right, you're back. And remember what this meant is 10 times 9 times 8 times 7. So if you had a regular calculator without the button, you could still do this. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. It really doesn't matter if you don't write the 1 down because anything times 1 is 1, right? Okay. How many ways? And anytime you see ways, you're talking permutation. So we want to be good at recognizing a permutation because tomorrow you're going to have to figure out permutation versus combination. Okay, if you were doing this by hand, this is the old-fashioned formula right here. Okay, how many ways can 3 bobsledding teams finish first, second, and third? So now this is a little bit different. This is a permutation because the question A just says how many ways can they finish. This one says how many ways can first, second, and third come in. So now we have a permutation. So there's a couple of ways to do this. One is with a formula, right? So there are 10 teams. And we want first, second, and third. Okay, so we want the first 3. So N equals 10, R equals 3. This is kind of the total. This is what you want. So I have 10 teams and I want to know how they can come in first 3 ways. So you can do this by hand with this formula. So that'd be 10 factorial over 10 minus 3 factorial. So you could type that in. Or you can think about it how your calculator does it now, which is 10p3. And if you have the really older calculator without the LED screen, you're going to type in 10, then math, PRB, 2, and then you'll type in the 3. If you have the nice new calculator, then you're just going to go to, let me clear that so I can do it with you again, math, arrow over to PRB, and choose number 2, and then it's going to set it up so you can just type it in, and you'll put in the 10 and hit your arrow key, you'll put in the 3 and you'll hit enter, and there are 720 ways. Okay, so use the calculator. Again, this is very, very easy because you're just using a calculator. The big thing I want you to pay attention to is how the questions are asked, because how they're asked is going to help you decide whether it's a permutation or combination. Now today we only have permutations, so that's all you can use. But tomorrow it gets a little harder because you have 2 sets of words. You have different sets of words. So permutation, look for keywords like order and arrange. These are clues for you that we are going to use a permutation and not a combination. Okay, let's look at a couple more. We're almost done. Okay, here's one you, well, I don't even know if you guys burn CDs anymore, but let's just say you're making me a playlist because I'm home bored over the break and you want me to listen to some good music. So you're making me a playlist and you have 12 songs. You only want to put 4 songs on, well, in this case, the CD. How many orders can you burn 4 of the 12 songs onto the CD? So in this case, we have to figure out what N is and what R is. You have how many songs? You got 12 songs. How many are you going to use? 4. So you got 12, you're going to use 4, so this becomes a 12p4. At this point, this is the brain work. You're done. Now you're going to type that into your calculator. So take a second. How do we do it again? Let's type this one in together. Math, slide over to PRB, pick number 2, and we're going to say 12, 12, arrow, 4. And there are 11,880 ways. So there are 11,880 ways to order the songs. So now you can think about your favorite singers and you get a CD, it's got 10 songs on it. How many different ways could they have put those songs? It's a lot, right? So again, your big goal today, I realize typing this into the calculator is very, very easy. Your goal is to recognize that you need the P and not the C, and that's where it gets harder once we have both. Again, what is the clue that's telling you? How do you know that that should be a P? There's your clue right there. Orders means P. What about if objects are not distinguishable? Obviously, if we put songs on a CD, they're all different. But what if we used letters like Monday? Is every letter different? M-O-N-D-A-Y. None of these letters are the same. So these are distinguishable. That means we can tell one from the other. What about Miami? These are not distinguishable because we can't tell the difference between that M and that M, and we can't tell the difference between that I and that I, so these are not distinguishable. That word is hard to write, right? Okay, so if they're distinguishable, then I can just do what we did in our very first example yesterday and say, okay, there's 1, 2, 3, 4, 5, 6. There's 6 letters, so 6 factorial equals 720 ways, right? Now this one, they are not distinguishable. So I am going to say that I have 1, 2, 3, 4, 5. I have 5 letters, so it's 5 factorial. But I have to divide out the letters that are doubles because I can't tell one M from another M. So my M's, I have 2 M's. So I'm going to put a 2 factorial here. And I have 2 I's. So I'm going to put a 2 factorial here. That's for the M. That's for the I. So you can just type that into your calculator. Do you remember how to get a fraction? So let's practice together. So we're going to go alpha y equals 1, right? So alpha, oops, y equals 1 will give you a fraction. And then in the top, we're going to put 5 factorial, 2 factorial, 2 factorial. And the factorial is math, PRB, 4, or PROB, whichever calculator you have. So let's try that. We're going to go 5, and we need the factorial button. So we're going to go math over to probability, or PRB, 4. Then here I'm going to do 2. But now I want to practice with you, so I'm going to go ahead and type that in. Okay. Do I need to put 2 factorial in? Well, 2 factorial is 2 times 1, so I could just put 2 times 2, but I want to do this. Okay, 30. So there are 30 ways that I can put these, I can arrange Miami 30 different ways. Okay. Now we're going to get to Tallahassee. So first you're going to count how many letters are in Tallahassee. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 factorial. And now I'm going to count my doubles. Did there any, there's not 2 T's, so let's do, I'm going to pick different colors so you can see them later. A. So I have 3 A's, so I'm going to do 3 factorial for A's. And then I have L's, 2 L's, so that's 2 factorial. And then I have 2 S's, so that's 2 factorial. Then I have 2 E's, so that's 2 factorial. Does it make sense to you how you count those? Anything that's doubled or tripled or whatever, however many of them are, you write a factorial. Then we just go to our handy dandy calculator, alpha y equals 1, and we do 11, math, PRB 4, and then I'm going to go into the bottom now. 3 factorial, you can either type 3 factorial in, or for me, if a number's that small, I know what it is. 3 factorial means 3 times 2 times 1, so that's just 6. So 6 times 2 times 2 times 2. Why don't we have to write a factorial with 2? Well, 2 factorial just means 2 times 1, so it's just 2. So it's too much trouble for me to write the factorial button, so I'm just going to do that. So we have 831,600 ways that we can arrange the letters in Tallahassee. And this kind of math is really important for anyone. If you were starting a company or a school or whatever, and you wanted to have passwords for all your people, you start to see that you don't need a lot of choices to get a lot of passwords, especially if you have several letters and you can allow someone 6 or 7 letters, like in Tallahassee. You could get a lot of ways. Okay, a circular permutation. What if we had objects arranged in a circle, or people? Let's say I put you in a circle in the middle of the room. Okay, if there's no fixed point, things are a little bit different than if there is a fixed point. Okay, if there is a fixed point, then it actually turns it into a linear, and it's simply n factorial. An example that you guys could think about would be a charm bracelet. Okay, if it has a clasp, meaning my bracelet is a circle, and then I can open it up, okay, then it has a fixed point, right? That's going to be a little bit different than if it doesn't have a fixed point. Now, if you think about a circle, well, actually I have a bracelet on. Let me take it off and I can use it and show you. Okay, so here's my bracelet. Is that's small enough for you to see? So this has, oh, perfect. So this is mine. I never take it off. But anyway, I have this bracelet on and I only have 4 charms. Pretend like I had 6 on there. But I want you to notice that I could put the bracelet this way, or I could put the bracelet this way, right? So because of that, we divide by 2. So if I have 6 charms, I'm going to say 6 factorial divided by 2. So that's 720 over 2, or 360 ways. Now again, this is if I have a clasp and I can open it up, because I can order them this way. I could also look at the bracelet from the other side this way. And a keychain, well, a keychain wouldn't work because I can't open it. Now, let's look at no fixed point. Okay, this has a fixed point, meaning a certain one is going to come first. Now, what if I don't have? Okay, so now my bracelet's hooked together, and pretend like the clasp isn't there, so I can arrange it. Now I can do it this way. Oops, hold on. There we go. So I can have my little bracelet this way, or I can turn my bracelet around and have it that way. So I look at it from 2 different points of view, so I'm still going to do that. But if it's not, and again, you have to pretend like I have 6 things on here because our example is 6. So how many ways can 6 charms be placed on a bracelet that has no clasp, meaning it's a circle and I don't know who's first or who's last? So then it's going to be 6 minus 1 factorial, still dividing by 2 because I can flip it. Now, this is for a bracelet, so we divide by 2. If I were going, let me add one to it, like a bracelet or a keychain, you can set it down and you can flip it over. That's why we're dividing by 2. If I had 6 kids in a circle, and I didn't know who was first, it would just be 6 minus 1 factorial. There would be no dividing it by 2 because I don't look at you guys. I'm not going to make you stand on your heads to get another circle. So that would be 5 factorial, which is 120. Okay, does that make sense? I hope that makes sense. I hope you have a great day. And your homework tonight is pages 19 and 20. And I will see you later. Have a great day.